Holy smoke. You're not going to believe where that freon is leaking out of. Look at the whole pan is filled with oil. I can't see it, but I hear it. Fortunately, it's not coming from the evaporator, which is good, because evaporators, they're not available anymore. Even though they're made out of copper, they can be fixed. So I'm going to take the compressor, lift it up, unscrew it, lift it up, and so we can get a better idea of where that's leaking from. Okay, so I propped up the compressor. I see the bottom of the compressor is all rusted. One of the studs is broken off. The pressure's building up. So let's just see where it's coming out. And you can see all the oil down there. Right, there it is. I don't know if you can hear that, and you get some bubbles. Look at that. You know what? In my 59 years in this business, I think this is a first. Holy cannoli. That is a first. Okay, so now we know what we have to do. We have to change the compressor, obviously. So, and fortunately for the person that owns this, the interior, the fan, the evaporator, all that is good. He only needs a compressor. All right, so I will talk to the customer and we will see what he wants to do. And then the first thing we will do is, if he says go ahead and change it, we'll cut the old compressor out, clean up the drain pan, and we have to re-weld one of these studs on in the back, and then we'll take it from there. Okay, so the compressor's out. You can see the mess in here. Rust. It's not really rust because this is stainless. One of the studs came off. I'll have to re-weld that. This is all full of oil. And here is the culprit. See that under there? The whole base of this compressor is rotted out. Like I said before, I've been doing this for a long time. I don't think I ever remember running into that problem. I've seen compressors where the fusites burn out, but I've never seen a situation like that. And I've been doing this for 59 years, and I did an average of 1,200 calls a year in my prime for at least 50 years straight, not counting the last 9 years. I've slowed down a little bit, but I'm still at it. So I have over 60,000 calls. That's a lot. So anyway, we know what we have to do, and stand by. Okay, we're back with this Northland refrigerator condenser module here. Let me get my light set up so you can see what I'm doing here. Now, this is the old compressor that we took out, with the bottom completely rotted out and rusted out. It's all rotted. They blew a hole in there and all the oil leaked out, and that's how the compressor burned out. So, this is the new compressor. This is an Embraco FFI 10HBX. This is a 1/3 horsepower or 134 unit, and it has a start capacitor, which we don't need because we're using this on low back pressure, but we'll put it in anyway. We're going to just have to remount this and relocate it like we did on the other Northland. The only difference in this unit, they're both the same models, NM13As, but this condenser fan motor is a clockwise motor, as opposed to the last Northland we did, which had a counterclockwise motor, and we had to order a clockwise blade and use a clockwise motor, but we don't have to do it on this machine, because as you can see, well, maybe you can't see, but it says clockwise. So we don't have to do anything there. The only thing we need to do to get this machine back up and running is put this compressor in there. So I removed the drain pan. This is a stainless steel pan. I re-welded the stud on here. This was broken off. And so in order to get this compressor into here, with these same mounting studs, the suction line almost touches the wall here. So as I did in the last Northland, I modified that by getting a piece of 5/16 tubing and making an elbow and cutting the elbow short so I can get this in further, and then bending this suction port over a little bit with my flaring block. And that's what we're going to do, so you can stand by and watch me do that. Okay, so here's a piece of copper tubing, and by the way, I recommend, if you have to buy copper tubing, do not buy it from overseas. Buy it American made. Now we got to shorten this elbow up a little bit, so I'm going to cut this down. So here is the cut down elbow. I could cut down this a little bit here, because that goes all the way into, let's see how far in that goes. Yeah, so you've got, what is that, half an inch, maybe a little more, 5/8. So we could cut 1/4 of an inch off there and still have enough meat in here to solder on. So let's do that. Okay, so this is how much we cut off. That's about 1/4 of an inch. So now we have a little bit more room to get this in there, and we'll check it out on the we'll mount it and see where the line comes out. That's the way it's going to be. Once I solder this in place, I'll bend this up a little more and then swage this out to go into this line right here. If I swage this out, now we're going to solder it in there. This is going to go right into here like that. All right, let's see what we got here. Yep. I did not bend the tubing. I just want to see how it looks without bending it, and it's right up against the evaporator, I mean the container here. So even though we shortened the process tube and put a 90-degree bend in the tubing, it's still touching. So we got to get our swaging block here, flare block, and put it over there and bend it so it's away from the wall. So we're going to use the 3/8. Okay, I'll put this on like this. Okay. So I moved it away from the housing and clamped it right on the joint. So now we're just going to bend this ever so slightly. We don't want to kink the line. That's enough. I hope that's enough. Now, let's try that. If it's not enough, we'll bend it again. Okay, it's not touching. That's good. So we'll bend this over, we'll tie it into here. What we'll do is we'll put a piece of foam in here just in case. I mean, that's just rattling up here, but it's not touching anything, and the compressor doesn't move. So you just want to make sure you have, I say there's about 1/8 of an inch clearance there. All right, let's get the this suction line soldered up. Recut that little elbow off there, right here, and we're going to tie this in just like that. Keep this low, and we'll just join it right there. Let me prepare that joint. Okay, so we're going to take a piece of this insulation text, Armaflex. Alright, just in case. Alright. Now, next. Okay, so before we put the condenser fan in, we have to hook up the discharge line. So I just want to get a visual on how this is going to look once this is in place. Just like that. So we want to come up with the discharge line this way, right into here. Because this is the dryer. The dryer was hooked up to this end. This is where the discharge line was hooked up to before. So let's do that, and then we'll put the condenser fan motor in, and then we can put the dryer on. Okay, we're going to do the same thing with the discharge line. Going to put a 90-degree bend in there, and we're going to come up like this, and we're going to come over right about there. Okay, condenser fan motor is in. Here's our connector. Everything is cleared. Now we need a filter dryer. Okay, I'm cutting this filter dryer down a little bit because it's a little too long. This will give me some more room. Now what I'll do is I'll put a piece of 3/16 tubing in there, and then put the cap tube into that. This is going to go like this. See, if I didn't cut that off, it would be hitting the bottom. So now we have to cut this and swage this out. Always check and make sure that that line is open and not pinched. Like when I cut it, wasn't careful in cutting it. I just cut it. So now I can see. But there's another way I do it, is I use a 16 gauge. 16 gauge is the third one in. 1, 2, 3. Just enough, cuts just enough through the tubing, and then you can just break it off and get a perfect hole there. Okay, so now we're going to take this piece of 3/16 tubing and we're going to put it in here. But before we do that, we're going to put this on here and get this sealed up so I can make sure that I'm not soldering that line shut. So we'll solder this onto here next. So now we got our dryer in there. We just have to bend it, move it around, and just get this capillary tube away from the compressor so it doesn't rub. We'll do that. And also, a word of caution here is, if that blade is made out of aluminum, don't direct the heat towards the blade or you'll melt that blade faster than an ice cream cone on a 100-degree day. Okay, so that's everything clears, everything's good. All our sealed system work, I believe, is done, so that I have to put one process port on here, which will be one of these. And then we will do a vacuum. And while we're doing a vacuum, we'll get this thing wired up and test it out. The cleaner you make this, the better your solder joint. Copper oxidizes quick, like aluminum. So somebody asked me the other day on my channel if I use flux on copper to copper. I absolutely do. Absolutely. And I learned that in school. That's the way I do it. Okay, so now you want to block that off so nothing gets burnt. Okay, that is that. So we'll let that cool down, pull a vacuum and do the wiring. But before we do a vacuum, we got to pressurize it, check for leaks, and I hear one. Right there. Okay. Let's fix that. Okay, we got it pressurized with nitrogen. Looks like we got about 125, 130 pounds pressure. I checked it for leaks with my leak sealer here. Everything looks good. So now I'm just going to clean up a little bit. I'm going to get the vacuum pump on it and leave the vacuum pump on for a few hours, and then we'll charge it with, let's see what we got here. We have 7 ounces. 7 ounces of 134A coming up. Okay, so here we are. We're back here. This unit's been sitting overnight. I just decided before I put the vacuum pump on there just to make sure that this thing is holding pressure. And we're looking pretty good here. So I'm going to drain the nitrogen out, and we're going to hook up our vacuum pump. Okay, we'll let this run for an hour or two, and then we'll charge it up and then wire it up, and we'll be done. Okay, now for the wiring. This is the condenser fan motor here. I'm going to just put some cable ties on here to keep that off the compressor. This gets snapped into here, and these two lines get connected to your overload and your lead on your relay, like this. Now in the last Northland that we did, we had to remove the capacitor because it was sticking out too far, and I was worried about it reaching the cover, interfering with the cover that goes on the front of the refrigerator. So we can do the same thing, but now it's hooked up. Okay, so now it's basically ready to start up. So we're still in the deep vacuum. We're going to weigh 7 ounces of R134 into the system. Okay. 1, 2, 3, 4, 5, 6, 7. Just a little bit extra for the hose. Yep, right on the money. Okay, so we'll put this right into our manifold here. Now we're ready to charge it up. And let's plug it in. Check the amps, 4.5. Let's let that go in there. We'll get all the freon in there, then we'll recheck it. Almost there. Okay, so when the pressure starts coming down, we'll know we've gotten all the freon out of the column. Okay, pressure's down, 11, 12 pounds PSI. Got all the freon out. Close our gauge. So now we got 4.7. So how many amps in a horsepower? 12 amps, right? Third horsepower, 4 amps. So we're pretty close to where it should be, and that's run amps. Start amps or locked rotor amps is 6 times the run amps. So we're looking pretty good here. Now we need to let it run. Cold air, really cold air coming out of there. Condenser's warm, which is good sign. Fan's running, pulling out air. I can feel the warm air. So we'll let this run for a while, and then pressure went down another pound or two, and then we'll put the covers back on and tweak everything here. So we're going to have to bend this filter over out of the way so it doesn't hit the cover, and then we'll put our covers back on, and this unit should be finished. One other thing I want to mention here, what I did was put this rubber foam insulation. I had a piece here. This is good stuff to carry when you want to insulate a pipe. And I also wrapped this line here with insulation tape just to keep it from vibrating. Alright, so let it run. We'll come back to it later and we'll button up this job. Okay, my friends, we are back. This unit's been running now for a couple of hours, 2-3 hours. The back pressure is at 10 and the head pressure is about 165 or so. That's a little higher than I would like to see it. And this back pressure should be, I mean, it's cold. The air coming out of there is really cold. But let me see if I can get a reading on the bottom here. 48. Not happy with this. I think it's possible we might have a restriction, partial restriction somewhere. I think the back pressure should be lower, but also it's possible that this condenser fan motor, I mean, it looks like it's running slow to me. And maybe we could try to put a stronger motor in there, because the tech sheet on the compressor recommends a 6-watt motor, but we never use 6-watt motors. We always use these compressors in 2.5 watt with 2.5 watt motors. So that could be a problem because it's running too hot. The temperature of the compressor is 129, 127. That's kind of like in the normal range. Alright, so we're gonna maybe pull that dryer off and see if there's any restrictions in the system. Can't let it go like this. I mean, this thing's got to be shipped back to I believe Indiana, and I want to make sure it's working properly. Okay, so now here we are. After doing this job and checking the pressures, I was not happy with what I was seeing. So we were running 165 psi on the discharge side, the high side, and 10 pounds back pressure on the low side. And to me, that's a little high. And there's a couple of things that it could be. One, condenser fan motor, which was turning and pulling air through the condenser, maybe isn't pulling enough air through, or we possibly have a restriction somewhere. So to be safe, I'm going to evacuate the system, pull all the refrigerant out, and change the dryer, at least check all the lines and maybe flush them out, because when I took the hose off the low side, some oil came out. So there could be some oil in the capillary tube which is causing this. Usually when the back pressure is a little higher than normal, it's because it's overheated or too much freon in it, something like that. So I just want to be sure, because this unit is being shipped in the middle of America somewhere, and I want to make sure it's working. The last one we did, we had about 5 pounds back pressure. But just to reiterate, for those of you that have gone to school and learned about physics, we were running 134A, and the correct head pressure for 134A in a room that's 70 degrees, you add the heat of compression, which is 35 degrees, that comes out to 105, and 105 on a 134A scale is 135 psi. So we're running 165. That's, in my opinion, too high. And plus we're drawing 4.7 amps, which is not too high, but I'd like to see it a little lower. Most of the time when I put these 1/3 horsepower compressors in here, it draws about 3.5 amps. And the condenser fan motor is also tied into this circuit, but that only pulls in about 0.7 amps. So that's what we're going to do. We're going to start from scratch. We're going to pull off the cover and drain the freon out. Okay, so we pulled all the refrigerant out. I only got out 5 ounces. So there's 2 ounces unaccounted for. And could have been in the hoses. I'm not too concerned about that. What I'm concerned about is that there is no freon in this machine. It's completely empty. It's in a 29-inch vacuum. The high side's open, and I can hear the valve in there. There's no refrigerant or air in the system. And look at that, we're drawing 4.3 amps on an empty system. That's, to me, is a little strange. So I'm going to get another compressor and check the amperage draw on it. Maybe this compressor is defective. Okay, so here's a 3rd horsepower compressor, same as this. This compressor actually came out of the first Northland I did. There wasn't anything wrong with the compressor, but the customer wanted to put a new one in anyway. So as a test, I'm going to show you. This is on no load on this. It's just running. It's plugged in. 2.7 amps. This is drawing 4.7 amps, 2 amps more than the 3rd horsepower compressor. I guess so. For another test, I can get another one of these. I have another one of these compressors, new ones, and we can check that, and then maybe determine if we have a faulty compressor. So we have a brand new compressor here. We're trying it out. We want to see what the amperage draw on it, just to check this one. And what do we got here? 4.4. That's not far off. And this is empty. That's empty. So I'm going to rule out the fact that compressor is bad. So we're going to look somewhere else. Just have a gut feeling that there's something wrong. I could be wrong, but it's my gut feeling. We're going to check everything out, and we'll see where we get. So now we're back. Here's what I did. I drained all the refrigerant out. I only pulled 5 ounces out. It takes 7. So I re-weighed the 5 ounces back in, and I'm checking the temperature of the air. It's been going down. I sealed off this compartment underneath these 4x4s to act as a little refrigeration space, so that the air, as it recirculates, the pressure will drop as the temperature drops. So right now I weighed in the 5 ounces of gas, and I also put in a little bit more vapor. We're below 0, which I like that. The high side is not quite 100, so I'm going to put some more refrigerant in here, because I was shy 2 ounces. So I'm putting those 2 ounces back in, but I'm monitoring it as I do it. So as the temperature drops, your pressure is going to drop. Before we were running at 10 pounds PSI, 165 on the high side. This gauge is not hooked up. I have one here. So we're below 100. We know that this compressor draws 4 amps when it's not under load, because we checked this one and also a brand new one next to it, and it was both 4 amps, about 4 amps, and 4 amps is a 3rd horsepower, so we're right in the ballpark. Everything's working fine, so I like to just keep adding some refrigerant in here, and the way we check it to make sure we have the right amount of refrigerant in there is not just by pressure, but you feel the suction line. See, like the suction line is getting cold right now. So, and what our temperature now is down to 27. So what happens is, as the air comes out of the evaporator compartment, it's recirculating like this, because there's an intake and an exhaust underneath the unit. So in order to properly check it, you need to seal that off so you see how far down the temperature can go. That's a barometer for me. That temperature on a Northland refrigerator, the freezer, it's like a freezer. The refrigerator gets its temperature, its cold air from the freezer through another fan and a duct, a little baffle control. So when the refrigerator needs cooling, a baffle opens or the fan comes on and it circulates the cold air from the freezer. And it's a very efficient system, the way that works. So what we do here, what we did here was to seal off this little compartment underneath the condensing unit. And so as the temperature drops, the pressure is going to drop, and that's what we're monitoring right now. So this is not looking so bad. I'm going to let it run. I'm going to cut out here now. I got to go to a Super Bowl party, but I will come back and we'll then recheck it. Okay, so here's where we're at right now. We just weighed in 7 ounces of 134A. I have a new gauge. Pressure is pretty good. That's like where I like to see it. So we just turned this on. We'll let it run for a while. And one thing I want to mention for you guys, you techs. Some guy reached out to me about this TPA 1413YXA compressor because he's following my video and replacing the compressor in his NM13A, which is the same as this. He asked me a question. He said, well, the manufacturer said that that's an R12 compressor. It is an R12 compressor, but it's also a 134A compressor. And it says it right here, 134A polyester oil. And that's the reason why you can use it for R12 or 134A, because of the oil. And the old R12 units way back used to use mineral oil. So you couldn't put 134A in an R12 system. But today, all the manufacturers seem to be using poly oil, so you can interchange the freons. You can use hot shot. I prefer to use what the manufacturer recommends. And also, since this is an R12 compressor, here is the serial tag for the unit, and it says right here, 7 ounces of 134A. So I hope that clears up any doubt about replacing this R12 or this TPA 1413A compressor with an Embraco. So we're going to let this run. We're going to put the cover back on and button up a couple of more things, and we should be finished. This thing looks pretty good to me. I'd say we were in good shape. All right, I will be back with a final conclusion. Okay, looks like we are just about done here. We got everything boxed up, packaged up. Just have to put it on the pallet. There's just one concern I have. I mean, the temperature's now down to 3.2 degrees, so the compressor's working, everything's good. Sounds pretty good. It's quiet. The only concern I have is there's water in the drain pan. Now that's normal because there's a drain tube right down there. Water comes out and it evaporates from the heat. And I think because the cover was off and the air wasn't being directed over the water to evaporate it, that's probably what causes it. I've never seen that before. But my concern is that the old compressor it was rotted out on the bottom of the compressor, which leads me to believe that maybe the water wasn't evaporating, and that's the reason why the compressor rotted out like that. I don't know. Maybe somebody out there knows. It could send me a notice or a comment to think about what it might be. But the other two Northlands that we recently did not have that problem. But I'm going to consider this fixed, and everything came out well. I can't really see in the drain. But The air that's coming out of there is slightly warm, which is a good sign. And the condenser is warm. The temperature's down now to 0, which is good. And we know we got the compressor, we got the right amount of freon in there. We're going to take a reading here. It should be around 4.7, 4.5. That's even lower. 6, 7, 5, 4.6. All right, so that's pretty good. I'm going to consider this job done. We'll see you on the next one.